This is problem number 13 on the second exam of spring of 2011. It says find the area of the region bounded by the graph of the polar equation r equals sine of 2 theta. We have done this problem before, but let's just do it one more time. So the first part is you recognize what this is, and this is a flower with 4 leaves. And so let's look at what this flower looks like. There it is over there. So one thing that you need to know is how far do you have to go to get one loop? Well, if theta is 0, you're at 0, so you're over here. And so you're at this point over here. And then in order to get half of one of these loops, let's see how far we're going. Look at this angle over here. So we're going from here. When we get to pi over 4, we get sine of 2 times pi over 4, which is 1, and we actually get to the point 1. So this angle here is really pi over 4. Okay, now that we've determined that this angle is equal to pi over 4, what we can do is we can just go ahead and set up our integral. So this is, you know that the area is equal to the integral from 0 to pi over 4, 1 half r squared, which is going to be sine of 2 theta, squared d theta. Now this isn't going to give you the whole thing. This is just giving half of one of these leaves. So how many of these halves do we have? We've got 4 leaves, and that'll be 4 times 2 to get one of them, because you're just using half of it, so we actually have 8 of these. Okay, let's multiply this out and bring it out. So we get 4 integral 0 to pi over 4 of sine squared of 2 theta d theta. Now let's use the half angle formula to get 4 integral 0 to pi over 4, 1 minus cosine. We double this angle, so we get 4 theta over 2 d theta. I'm going to bring this 2 to the outside, split this up into 2 integrals. So you have 4 over 2, which is 2 integral 0 to pi over 4, 1 times d theta, which is d theta, minus 2, because this 2 is in front of everything, right? 4 times 1 half is 2. That negative is over there, and you get integral 0 to pi over 4 of cosine of 4 theta d theta. So now this is 2 times the integral of d theta is just theta from 0 to pi over 4, minus 2, the integral of cosine of 4 theta is sine of 4 theta over 4, and we do this from 0 to pi over 4. Now let's substitute pi over 4 in first, so we get 2 times theta pi over 4, so we get 2 times pi over 4 minus 0, which is just pi over 4, so we get 2 times pi over 4. Now over here, negative 2 times, substitute pi over 4, and you get 4 times pi over 4, which is pi. Sine of pi is 0. So you get 2 times 0 over 4, which is 2 times 0, which is 0. When you substitute 0 in, sine of 0 is 0. So there's your answer, and you just get pi over 2.